All right, this is pre-algebra lesson 4.3, prime factorization and greatest common factor. Okay, you guys have been doing greatest common factors for a while. What are factors again? What does the word factor mean? Sheena?
Like a number,
That can be divided into another number. What's the word? Evenly, right? Every other number, I mean, any number can be divided by any number, right? I don't care what the number is. Can you divide it by another number? Of course. Does it go in evenly? Those are the factors, right? We've talked about this. What are the factors of 20?
1, 2, 4, 5, 10, 20.
Good. You know the factors of 20 because all of these numbers go into 20 evenly. They each have a pair, right? They each have a partner that you can multiply that an integer by an integer, and they all, it goes into it evenly. Anyway, that's what factors are. Good. What is the difference between a prime number and a composite number? What is prime? What does a prime number mean, Kyla? No, don't even say that. There's a very specific mathematical. It has to be odd. If it's an even number, then it's definitely not prime. Sheena?
It's like something that doesn't have a number.
That is the poorest excuse for an explanation ever. It's something that doesn't have anything that goes in something. No, use math terms. Use math jargon. You're in pre-algebra now. Use math jargon.
Like a prime number is like.
Listen, it's not like. Prime number is, Amy.
It only has two factors.
Thank you. It has only two factors. A prime number is a number that has only two factors. What is every number has two factors? What are they? Every number has two factors. One in itself. There are exceptions to this. What are the exceptions to that? What is the only two numbers that don't have two factors? Jack, 1 and 0, right? Those are the exceptions to the rule. 0 technically is a placeholder. It's not a number at all, right? It's an absence of something. But whatever. 0 and 1 don't have two factors. Every other number has two factors. So a prime number is a number that only has two factors. A prime number has only two factors. Is the number 2 a prime number?
Yes.
What are the factors of 2? 1 and 2. Is 3 a prime number?
Yes.
Yes. Why?
It's 1 in itself.
1 in itself. 1 and 3 are the only factors. What about 4? Is 4 prime? Why not? Why is 4 not prime? What's the reason? Use the math terms. What? Why? It has another factor. It has more than two factors, right? Every even number other than 2 is not prime because what is for sure a factor of that number if it's even? 2, which means that there's 1 itself and 2, which means it's not going to be prime, right? That's why prime numbers are generally odd. The only exception to that would be 2, right? How do you know if a big number like 79 is prime? What is one way of figuring out if a number is prime? Big, ugly number. What could I do, Jack?
Divisibility.
Use the divisibility rules. You go, okay, is that divisible by 2?
No.
Why not?
Because it's odd.
Not, it's an odd number. Is it divisible by 3? 7 plus 9 is 16. Is 16 divisible by 3? No. What about 5? Is 5 divisible? Is this, no. 6, 7, 8, 9? No. 10, nope. Then it's probably not. The ones you'll get in trouble with are 91. That's a tough one. 91's a hard one because it is not prime. It's not prime. You go, okay, is it divisible by 2? No. What about 3? No, that's 10, no. 5, no. 9, no. 9 plus 1's 10. That doesn't, no. What about 10? No. This is 13, right? 13 and 7, right? So it's a 7, and that's a tough one. And those are the ones that if you happen to miss that, yes, it's still wrong, but this is 1 and 91, and then you also have 7 and 13. But that's a tough one. And so if you miss 91, I'll get it. It's one that you could probably memorize. that 91 does have more than one factor. Anyway, so that's prime numbers. What is all other numbers called? If they're not prime, then they are composite. Composite numbers. What does the word composite mean then? If prime numbers are numbers that have only two factors, what are composite numbers, Amy? Has more than two factors. A number that has more than an integer that has more than two factors. That's what a composite number is. So 4, 6, 8, 9, 10, they're all composite numbers because they have more than two factors. Agreed? Okay. You with me, Gigi? Okay. Here's the deal. I'm going to start showing you now. Have you ever heard of finding whether or not, I'll just take a step back. Prime factorization. Have you ever done that before? I believe you did last year. Prime factorization. Prime factorization means this. I'm going to take a number and break it down into its prime factors. I'm going to take a number and break it down into its prime factors. What is a prime factor again? What's a prime number? What's a prime number? Two factors. So I need to look at whatever I do here, when I come up with my answer, it's going to be a set of prime numbers. Prime factorization. Let me give you an example. Here's the number 60. I'm going to do prime factorization of 60. What that means is this. I need to break 60 down into its prime factors. What are some factors of 60, by the way? 1 and 60, 2 and 30, 3 and 20, 4 and 50, right? There's a lot. I need to break this into its prime factors. So what I'm going to do is this. I'm going to take 60 and I'm going to break it into two factors. What are two factors of 60?
1 and 60.
1 and 60. We never do that. Whenever you're doing prime factorization, we are back to where we started. So we never do that. Anyway, Jack, give me two others.
5 and 20.
5 and 20. That's not true. 5 times 20 is not.
5 and 15.
Nope, 5 and 15 is no good either. 5 and 12. There we go. So listen, shh. Two numbers that multiply to 60 are 5 and 12, right? So this is what you do. You go look, okay, is 5 prime?
Yes.
5 is prime, you circle it. It's prime. I'm done with that. That 5 is now done. It's a prime number. The factors of 5 are 1 and 5. That's it. Factors of 12. What are two numbers that multiply to 12?
2 and 6.
2 and 6. Okay? Is either one of those two numbers prime?
Yes.
Which one is?
2.
2 is prime. It's done. 6. What are the factors of 6? 2 and 3. Are either one of those prime?
Yes.
They both are prime. I now have all of these numbers are prime. Look at this. Here's how you write prime factorization. You take all the numbers you've circled and you go, okay, it's 2 times 2 times 3 times 5. What is 2 times 2? 4. 4 times 3? 12. 12 times 5? 60. We're done. This is actually not written in prime factorization. This is really close. What do you think you have to do to make it better?
Exponent.
You put an exponent. So this would be 2 squared times 3 times 5. You want to put them in numerical order, right? They start with the lowest one, 2s, then 3s, then 5s, etc. That is 60's prime factorization. Does that make sense? Okay, let's try another one. I'll do 75. Pay attention here. The prime factorization of 75. I have to find two numbers that have a product of 75. What are they? Give me some. 3 and 25. Now, I have a question. I'm going to do 75 over here. What if I didn't do that? What if I did 5 and 15? Don't you agree that 3 and 25, 3 times 25 is 75? What about, is 5 times 15, 75 as well? Yeah. Is one of them right and one of them wrong?
No.
They'll both work. We're going to do them both ways just so you can see that it doesn't matter. Is either 3 or 25 prime?
Yes.
Which one?
3.
3 is prime. Circle it. It's done. That part of the tree is over. 25. What are the factors of 25?
5 and 5.
5 times 5. Are either one of those prime?
Yes.
They both are. We're done. Okay, that means the prime factorization of 75 is 3 times 5 times 5, which can be written 3 times 5 squared. Make sense? That's 75. Let's go over here. Let's just say that I decided to do 5 and 15. Either one of those two prime? 5 is 15 prime?
No.
What are the factors of 15?
3 and 5.
3 times 5. They're both prime again. Oh, look, 3 times 5 times 5, which is 3 times 5 squared. It's the same thing. It doesn't matter which, as long as you're doing this, guess what they're all going to boil down to? They're all going to boil down to nothing but the prime factors. Does that make sense? Nothing but the prime factors. So anyway, I'm going to give you guys one to do. This is kind of a nasty one. Let's do 200 and no, we're going to go 450. It's a good one. 450. All right, here we go. You're watching. Lots of choices here with a big number like 450. Lots of choices. Up here, guys. Eyes up here. Whether you're done or not, eyes up here. Eyes up here. I'm not kidding. Leave them up here. 450. Yes, you know it's even. You could go 2, but then you want to do this, whatever's going to be the fastest, right? I mean, like, so, what are my choices here? What are some easy choices here? I see 450. Obviously, one of the factors is going to be 50, right? So that'd be 50 times 9. I could have chose 50 times 9. What else could I have chosen that would have made this really easy? I see a 0 here, which means it's divisible by 10. I could have chosen 45 and 10, right? I could have chosen lots of things. You can do 2 and 225. I mean, does it matter which one you choose?
No.
Not at all. Eventually, it's all going to boil down to what it boils down to, the prime factors. So let's do 9 and 50. Are either one of those prime, 9 or 50?
No.
They're not prime, neither one. Okay, what do I have to do then? I have to go, what are the factors of 9?
3.
3 and 3. Are either of those prime?
Yes.
Both. 50. What could I do here? I could choose 2 and 25. I could choose 5 and 10. Which one do you want to do? It doesn't matter. 5 and 10. Are either of those prime?
Mm-hmm.
Which one?
5.
What about 10? 2 and 5. Here we go. Prime factorization of 450 is 2 times 3 squared times 5 squared. How many got that?
I didn't finish, but I
You were on the way?
Right. Yeah.
Okay. Does it make sense? Does it? Okay. Hope so. Here's the deal. I show all of this to you so that you will understand how to find the greatest common factor. Remember greatest common factor? Greatest common factor is like if I have this 20 and 15. What is the greatest common factor means biggest same factor. What's the biggest number that goes into both those? 10 goes into 15? 5 does, right? 5. Most of you can do these small ones in your head. Agreed? The greatest common factor of 20 and 15 is 5. What are the factors of 20? 1, 2, 4, 5, 10, and 20. What are the factors of 15? 1, 3, 5, and 15. What's the number is the greatest common factor, greatest same factor? They're right there. It's 5. Agreed? You see what I'm talking about? You've done this since what, like 3rd, 4th grade? I mean, you know how to do greatest common factor. Anyway, what about when you get something like this, though? When I give you one like 425 and 575. Big numbers. Or I'll even do something like this. I'll make it 225. All of a sudden, now you go greatest common factor, and oh boy. Okay. Here's how you do it using prime factorization. Are we all watching here? Here's how you do it. Find the prime factorization of 425. What for sure goes into 425?
25.
25 does. Could you do 5? You know it goes 5 does. That would be a little bit more work, but if you could do 25, that's great. How many times does 25 go into 425?
9. Oh, 425, sorry. 17.
17, that's exactly right. 25 and 17, not 25. It is 25, yeah. 25 and 17. Are either of those prime?
Yes.
Which one?
17.
It's 5 and 5. Agreed?
Yes.
So the factors of 425
17.
are 5 times 5 times 17. For this, you want to write it out the long way. 225, what number goes into 225?
25.
25 and 9. Are either of those prime?
Yeah.
No. This is 3 and 3, and this is 5 and 5. Okay? So the prime factorization of 225 is 3 times 3 times 5 times 5. Here's how you do this. Find me the common factors of both. What are the common prime factors of both? I have this, look here. I have a 5 here, and I have another 5 here. Do you see what I'm talking about? That's the two common prime factors. What is 5 times 5? 25. Guess what the greatest common factor of 425 and 225 is? 25. Does that make sense? I'm going to show you one more like that. I'll make it a little bit easier. I'm going to go 48, and 80. Okay, 48 and 80. How do we do this again? Well, how do I find the greatest common factor of two numbers using prime factorization? Jack, what do I do?
You can do 8 times 10.
No, but what do I do?
Oh, you.
Use the words. So if I said explain it, how do I do this? How do I find the greatest common factor of two numbers? What is one method I could use? Prime factorization, right? So I'm going to find the prime factors of 48. You said 8 times 7? That's a lie.
No, I said 8 times 8 times 10 for 80.
Oh, right. We're doing left to right. Left to right, right? 48 would be 8 times 6. Are either of those prime?
No.
Okay. 8 is 2 times 4. Are either of those prime?
Oh, yes, 2.
2 is prime. 4 is 2 times 2. 6 is 2 times 3. All prime numbers now. The prime factors of 48 are 2 times 2 times 2 times 2 times 3. Agreed? Shh.
Oh, wait.
Shh. The prime factors of 80, 8 and 10. Are either of those prime? No. 2 and 4. 4 is 2 and 2. 10 is 2 and 5. So the prime factors of 80 are 2 times 2 times 2 times 2 times 5. What are the prime factors here? What are the common prime factors? 2's, 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 2's. So now what you do is you're going to multiply this. You're going to go, okay, what is 2 times 2? 4. 4 times 2, 8. 8 times 2 is 16. The greatest common factor of 48 and 80 is 16. Make sense? Make sense?
Yes.
Jack?
So, it's just multiplying the groups.
Yep.
Got it.
Yep. What about this? Hold on, I'm going to change this. Okay, algebra, right? So pay attention here. This is new. You have to know how to use prime factorization and understand what is going on here. Using prime factorization here. I see a bunch of letters. You see them? A bunch of variables. Ignore those for now. In the end, we're going to write them all as prime factors. In the end, just watch. What is the prime factorization of 24? What do I do? 2 and 12 works. 2 and 6 works. 2 and 3. Yes? Okay. So the prime factorization of 24x squared y is 24x squared y is 2 times 2 times 2 times 3 times x times x times y. Does that make sense?
Yes.
Do you see what I did? I've just written them all out. I've broken it down as much as I can. For 40, I have 4 and 10, which is 2 and 2, and 2 and 5. Agreed?
Yes.
So then 40 x, y, z squared equals 2 times 2 times 2 times 5 times x times y times z times z. What are the common prime factors? 2, 2, 2, x, and y. So then you're going to take these and multiply them all, right? I'm going to go 2 times 2 times 2 is 8, and then I have x times y is just xy. 8xy is the greatest common factor of 24x squared y and 40xyz squared. Does that make sense? Simply follow the instructions, follow the pattern. I'm going to give you one of these to do. Just one. Here we go. 15 m squared n and 45 m. I want the greatest common factor of 15 m squared n and 45 m. Okay, here we go. You're watching. Take the numbers. What is the prime factorization of 15? 3 and 5. And they're both prime. So 15, notice this. I write this right on top of each other, right? I actually take them and I write them right on top of each other. Write them right on top of each other, right? So the prime factorization of 15m squared n is 3 times 5 times m times m times n. Agreed?
Yes.
On top.
Agreed.
On top. Next one. Prime factorization of 45m is 5 and 9. Are they both prime?
No.
No. 3 and 3. Now they're prime. So then the prime factor of 45m is 3 times 3 times 5 times m. Right?
Yep.
Right on top of each other. Right on top.
Yep.
Now, I'm going to pair them up, right? You do what I do. Pair them up. Find the common prime factors. Where are the factors that are the same in both? Well, I have these 3's here. I have these 5's here. And I have those m's there, right? Those are the common factors, the common prime factors. Take them and multiply them now. What is 3 times 5? 15 times m? M. 15m. Make sense?
Yes. Yeah.
Make sense? Okay. I don't think there's anything harder than that. The only thing that you may have to... Nope, that's it. Other than that, you can do it. Okay? Here's the deal, listen. When you give me your answer, you have to write it using exponents, right? In the actual answer column, write it using exponents. When you're going to actually find the greatest common factor of two numbers, you shouldn't write them as an exponent because you want to be able to circle them. You know what I'm saying? But when you actually give me the answer, it's got to be, 4, it wouldn't be 4. 3 to the third times 5 times x, not that, times 5, if they're asking for that. If they say give it in prime factorization, that's prime factorization. It is not 3 times 3 times 3 times 5. That is not the right answer. You understand what I'm saying? You use that to find the greatest common factor, but anyway, your homework. And then hopefully I have a second to update your grades. We'll see. Killing me. Page 189, 1 through 42. Even. Now, one last thing before I do this. Sometimes they give you this. What if I gave you this? 15m squared n, 45m, and I also gave you 60n squared and said, what is the greatest common factor of all three? What do?
Prime factorize.
Nothing. You prime factorize all three and you lay them right on top of each other, all three of them, and you got to find the common factors that are in all three of them. And then it's the same exact process. Nothing changes with the process.
So we have to write it out.
Yeah, why wouldn't you? Okay. There it is.